Okay guys, welcome back to part 2 of this tutorial to show you how to print from Fusion 360. Okay, so let's quickly recap. You can see here that I'm actually in the Flash print program. The file has come in from Fusion 360, and you also see that the thread has not appeared here on the outside of the actual item there. So if I did want that thread to appear or to be a real thread, I'll just go back and show you. You can see here the thread at the moment looks like it's there, but it's not. If I did want a thread, I'd actually have to go back into that thread, which is back here somewhere, and I'm going to edit that feature, and I would actually have to click on model the thread there, and it actually does make a real model thread. I actually might do that just to show you. So I'm going to click OK. I'm going to re-export this as a 3D printed object once again. Leave everything the same way it was, select the object, and hopefully don't get the spinning wheel there for too long, and click on OK. It should then open this up in, there it is, Flash Print. Now that's interesting, it's put that second one next to the first one. So what I'm going to do here is delete the first one because I actually want to print this with a thread. So to delete something in Flash Print, you select it, hold down your Command and then Delete button. You can also use Edit, Delete up here as well. Okay, so what we need to do now is work out the best way to actually print this object so that it uses the least amount of build material or support material, but also still gives us the necessary detail that we need. Now, if I was to put support material on this right now, it would fill up a whole lot of this underneath here. So I'm going to show you what I mean by that. So I'm going to click on this support icon here, and then I'm going to click on auto supports just to show you what happens. And I'll click OK. And you can see here, well, it actually hasn't done too bad. It's just got these trees going between the thread here and underneath this surface. It's actually not too bad. If I did change those support options back to the defaults, I'm just going to show you what I mean. I think it will be slightly different. As you can see, quite a bit different here. All right, so what we're going to do is we're going to show you how you can rotate this around so that it's not sitting on this surface, but it's sitting on this surface here, which then should negate the need for any of this support material at all. So I'm going to clear those supports, and I'm going to use some of these tools over here on the left-hand side. Now that's just been a bit weird. I'm just going to up out of that, go back in there again. Oh no, it's being a bit strange. I'll just make that full screen. And I'll go back. There we go. All right. So whenever you're manipulating or moving this object here, these tools will only work when they're highlighted. So at the moment, I'm in the View tool. So let's click on View. And by clicking on these different icons here, we get different orientations. Top view, bottom view, left, right, back, front. And then if you want to go back to isometric, you hit Reset. That's how you control views. If you want to move the object, you first of all have to click into the Move tab, then select the object, and then you can move this in a number of different axes, different directions, or you can simply grab it dynamically and move it around as you like. You'll notice here that there's a very important tab called On Platform, which means that it's going to move it so it's touching the platform or the base of the printer, and also the center button, which moves it directly into the middle of the actual pad there. I'll just try to show you what I mean here. If I move that outside there, see this red wall appears. It means it's outside the printing envelope, so I've got to move it back in there. I'll try moving it up the Z to show what I mean too with the center. So if I center that, and then if I unplatform it, now it's actually touching. But we want to rotate this thing, so I'll go to the Rotate command. And you'll see you've got 3 orbs of rotation, an X, a Y, and a Z. Now, I try to avoid grabbing these actual lines and doing this manually. I think that's thought with a little bit of trouble. So I'm just going to undo that last thing I just did, edit, undo. And I always tend to click into these different parameters up here, either adding 90 degrees to a rotation or subtracting. What it will do then, it'll actually rotate that 90 degrees. So I want to flip this thing in the y-axis once, so I click there once and click there again. You can do fine control by doing it here as well, but that's basically the orientation. I'm going to turn it upside down. I also want to click on surface to platform, and if I go back to move, on platform there. So now my object should print with the minimal amount of build material. I should only get a little bit inside here. Thread should be well created, and because I don't really need this top surface here, it's not really seen that much, it doesn't matter if it sticks a little bit to the brim that we're going to print there. Alright, so while I'm there, I should also discover scale. So if I click on scale and you click on the object again, you can then actually scale things up and down in X, Y, and Z if you want to keep it uniform. I'll just show you what I mean. I think by going, if I went maximum, that's interesting. Okay, max is as big as it can on the screen. Back to reset, takes it back to there. You can see here by Z axis, if I uncheck this, I could even do one axis and not the others and so on. I don't normally use scale a lot, so I'm going to hit reset there. The cut icon or the cut function can be quite handy if you want to separate pieces. Let's say we wanted to cut this thing down the middle, only print half of it. If I click on cut, and I tend to use a plane to cut with, so I've got an x-axis or a y-axis or a z-axis. So let's say it's going to be sectional, so I'm going to choose that y-axis, and it just happened to default through the middle. If I leave this bit unchecked and hit start cut, it then splits the two apart, and you've now got two different pieces. If I just go back and undo that, and if I go keep parts in place and hit start cut, there's actually two parts there now you can see. I just need to get out of the cut, I need to get back into the move, and you can see those two parts can be moved apart. So that's the cut. Cut can be used good for separating parts out. So we go undo. Probably should just do Control Command Z, shouldn't I? And the last thing is this one called extruder, which one you're choosing. And once again, we're always going to be using the right-hand extruder. Don't check the left-hand extruder because we actually don't use that on the machines. It's to do with the plastic and it getting brittle and so on. All right, so you've got your object in the correct orientation, it's sitting on the bed there, and you're happy at that point. Let's test to see what these supports are going to look like. So the first thing I'm going to do is click on supports, support options, and I was going to click on, actually this was the default. So the default one is tree-like with a 45-degree overhang, a post diameter of 6, base of 6, and base height. Now I know this object is actually only about 60 millimeters long and about 24 millimeters wide. So I happen to know that a post diameter of 3 and 6 and 6 is going to be excessive. So I'm going to reduce that down to 2, the diameter down to 4, and the height also down to 4. I click OK, and then when I click on auto support, you'll see it then calculating the supports, and you can see then, I'll just click on OK again, if I zoom in with your mouse, you've then got the support material put in as trees to support the print as it creates every single layer of print. It actually works from the bottom up. Alright, if you weren't happy with that, if it was full of support material, you wanted to try something else, you simply click on clear support. We might muck around with that support options again, see what happens. I'm going to go back to restore those. Okay. Auto support again. I think I need to select it. Auto support. Yes. There it does. And my goodness, it looks like I haven't even needed any support at all. So that's pretty cool. If I can't quite see in that hole there, but you should see some green in there if there's any support material required. So what it's managed to do here with those different parameters is actually said, you know what, we're going to print this so that it doesn't require support material. That's really cool. All right, so once you've done your supports, then click on the back icon here, and it's prompting you to say, do you want to save this file now? You want to say yes, because at the moment this file is only a unsaved STL. Well, it's actually going to store it as an FPP file. So we say yes to that. And here is really, really important. You must make sure that you save your work into a common folder all the time. So I've got my drive set up here. This is for grade 11 industrial tech skills. There it is there. It's the project of the folding shovel. And you must give it a correct name. You'll see that for some reason it gives it this hideously long name. I'm going to call this one, this is actually the bolt, not the nut, sorry. Bolt 3D, and then click on save. And that's now saved that as what we call an FPP file. The last thing to do is to then set the parameters for actual printing. Now at this point you could take your machine to the printer if you wanted to, or you can do this before you get there. So you can do this at home or any other time. So the last thing to do is to then hit the print button. And we would need to go through some of these options here to explain what's going to happen. All right, so we want to preview, that'll do. The profile is the Inventor PLA, standard. Now this is where you can choose like the quality, I suppose. So if you want to do something quick that wasn't as good quality, you could set it to low. Obviously the higher you go, the longer it's going to take. Hyper being the absolute best resolution whatsoever. So I'm just going to experiment with hyper, and you really don't know how long it's going to take until you muck around with these different ones. Okay, then come down to this next tab, General, and the thing I need you to change is this first layer height. I need you to click on the arrow here, and you'll see that we'll keep going up until it gets to 0.4 millimeters. That's the thickness of the first layer of plastic of your project. It's going to make it 0.4. By making it 0.4, it makes that first layer nice and robust or stronger, and it's less likely to break away if it gets stuck to the support material. So set that to 0.4. Everything else stays as it is for the general. Then come across the next one called perimeter. Perimeter, once again, you should not need to change anything. Next one across is infill. And infill is where you may want to make a change. All right, so it's going to say the top solid layers are going to be 6 and the bottom solid layers are going to be 6. So that gives you that thick sort of top and bottom to your project. The next one's really important. This is how dense you actually want the object to be. Now, I happen to know that I've printed this before at 15% density, and that means inside here is a bunch of quite thin hexagons, if you like. And when I've printed it and then put it together, it's actually sheared off through here. I'll show you what I mean by that. But actually now I'll leave it at 15%. I'll leave the fill pattern at hexagon. I'm going to click OK and come back and change these other things in a second. Actually, I'll print one at 15% and then I'll do a different one. Click on supports, and we can leave that all as is. Click on to raft. We don't want a raft. The extruder is the right one. This one here we need to change as well to 0.4. This basically makes the raft and any of the brim easy to pull off if you do use a raft or a brim. So keep on going there until you get to 0.4. They all stay the same. And additions, and that stays the same there. But over here you see an icon called brim. Now brim is basically a small circular pad that helps any tree-like structure grip to the table it's been printed on. So change that from brim no to yes, and let's go then to advanced and others, and all of that is correct. So before you then click OK, make sure you click Save Configuration, so then you don't have to do the whole thing all over again. And click once again, OK. It's going to ask you where to save it to, and you notice that the file type changes from the standard FPP file to a GX file. The GX file is the X, Y, and Z coordinates that get sent to the 3D printer, which is what it understands. A GX file is not editable, so you can't open a GX file up later on and change something. You have to open the FPP file. You can see there's the FPP file there. Click on Save, and you'll see it's doing all the slicing. Wait for that to finish. And then you can see here, we've got a bar that we can pull down to show you all of those slices and how they created. And if you look inside, I might zoom that in a bit, you can see that the amount of infill is quite, not much there at all. It's 15% of infill. So that's okay until those two parts then join together about, where is it, about there. So what happens is for this project, there's a nut that screws down on top of here, and it meets here, and there's a fair bit of shear pressure between the nut and this bolt. So when I first did this at 15%, these pieces were shearing off here and breaking off around the mouse. So I then had to go back and change that density from say 15 to like a maximum of say 50. So what I might do is go back, and I'm going to go to print again, and I'm going to go into infill and change it from fill density of 15 up to 50. Click OK. Save. No, I'm going to not save that configuration because that's a bit of an anomaly. So I'll click OK. I'm going to save it again. I'm going to call it the same thing. Yes, going to overwrite what was already saved. It slices it up again, or puts down the layers, I should say. And you can see here when I get down, you can see the difference in the density of the hexagons. So it's a lot denser, and the size of the hexagon is determined by the density that you set, which is going to make that a lot stronger and less likely to shear off or break off there. So it's always good to check that to see whether you think the object is going to be dense enough to be able to live up to what it needs to do. And looking there, I can also see there's one little tree that it's actually printing inside that hole there. Amazing how it decides to do one little bit there and nowhere else. But anyway, that's cool. You then notice here it gives you a print time and also the estimated amount of meters of PLA material that's going to need. So this is where you then have to get a bit of masking tape from the printer area. You need to write your name on the bit of masking tape. You need to write the estimated print hours that this would take. So this would be 2.5 hours. And you also need to write the time that you started your print. So I'll get that again, your name, the amount of hours that it's going to take to print, and the time that you started your print. And with that bit of masking tape, you then put that onto the yellow, sorry, not the yellow, the white bottom rail of the exterior part of the printer. We click on print. It would then ask to connect. Obviously, I'm not connected to the printer at the moment. You'd select the machine down here, and then it would go off to the printer. And we'll create a video on actually how to then, well, actually, as soon as you hit connect, it will then send this file to the printer, and the printer will start working. All right, that's about it. There's a fair bit to go through there. Remembering those settings, make sure you hit save configuration so that each time you don't have to change those again.